All right, welcome geometry kids. I'm trying to record something via different. I'm doing screencast-o-matic today, so we'll see how this goes. So we're introducing lines and segments that intersect circles. So there's going to be lots of vocab for today. So we need to talk about circles, radius, chord, diameter, secants, and tangents. All of these definitions are found in your book on page 529 and 530 going into your book. So on page 530, you will find these definitions. So in a circle, a chord is a segment that has both endpoints on the circle. A secant is a line that goes through the circle. A tangent, which is this green thing down at the bottom, only touches the circle in one point. That point that it is meeting at is called the point of tangency. Now, what is the largest chord in a circle? The largest chord in any circle is going to be the diameter. Okay, largest chord in any circle will be the diameter. All right, drawing two tangents to a circle. So we can have internal tangents or external tangents. So here, if we're going to draw one tangent, this tangent would come down and it can touch both of these circles in just one point. And here we can draw a tangent that would go through and cut on the top 1 point, 1 point, and come down here and touch 1 point and 1 point. So those are called internally tangent circles or externally tangent circles. All right, find the length of each radius. So if we look at this largest circle with center at point D, if you count out 1, 2, 3, you can see that that radius is 3. Well, you can also count 1, 2, 3. So the radius of circle D is 3. And if you look at C and just count, this radius is only 1. So find the length of each radius and identify the point of tangency. Well, that point of tangency where the two circles meet is going to be right here. So that ordered pair is going to be at 2, negative 1. 2, negative 1. And then they want to know what the equation of that line is. And the equation of this line right here, horizontal line, it is crossing only the y-axis. And where is it crossing y at? It's crossing y at 1. So the equation of the tangent line would be y equals 1. And the point of tangency of those two circles is at 2, negative 1. All right, looking in here, if you look, we've got that big circle with the center at D, and if you look at AB, that is a tangent to that. And what do you think that green line is, DB coming down? DB coming down is a radius. And if that radius is going to meet at this point of tangency, point B, then that radius, dB, must be perpendicular to the tangent. So if the radius is meeting at the point of tangency, that radius and the tangent will always be perpendicular to each other. All right, so here's where they're going to use this. They're going to draw this tangent. So they're telling you RT is tangent. So they're telling you that R is that point of tangency. So they're not going to draw it in, but what they're going to do is expect you to know that when we draw this radius down, and if it meets at that point of tangency, this must be a right triangle. And if that is a right triangle, and if they're telling you right here that QS is 7, then how long is QR? That must also be 7. So now you can do this a couple different ways, and I'm probably just going to count this as X right here. So I'm going to use my Pythagorean theorem, and the two legs that come together are 7 squared plus 24 squared has to equal x squared. So 7 squared plus 24 squared is equal to 625, and then the square root of 625 is going to be 25. So the length of x is 25. Well, if this whole thing x is 25, we're going to take 25 minus 7 to get that length of st. So 25 minus 7 is 18 for that length of st. Now, like I said at the very beginning, they are not going to draw that in. They're going to expect you to know that when you take from Q, from the center, to that point of tangency, that is going to come down and make a right angle in here, and then you're going to be able to use your Pythagorean theorem. All right, common tangents that they have here are common internal or external tangents. So if you have two circles that are separated, you can have internal tangents where you draw them between, or common external tangents where you draw them on the outside. Those are just called common tangents. All right, concentric circles are just your big crazy bullseye. Concentric circle is every circle that shares the same center. So if you look at every black circle or every white circle, they all share the same center right here. So concentric circles are circles that share the same center. All right. If we were in school, we would have gone in and done an investigation here, and we would have made AB tangent, and we would have made AC tangent, and then we would have measured that length of AB and that length of AC, and we would have found out that those two lengths are always equal. So if those two lengths, AB and AC, if B and C are both tangents, those lengths will have to be equal. That's one of the theorems for this chapter. So they're telling you from point H, HK is a tangent, so that's your point of tangency, and HG, this is a point of tangency. So if they are both tangent, they're telling you that this segment must be congruent to that segment. So we can find out the length of HG by saying 4x squared must be equal to 28x. So if I divide this by 4x and this by 4x, these x's cancel out, and one of these x's canceled out, so you're still left with one x, and the 4's cancel out, and 28 divided by 4 is 7. So now to find HG, plug your 7 in here. So we have to go 4 times 7 squared, and 7 squared is 49, and then 4 times 49 is 196. Now, could we have just taken 28 times 7 and gotten the same thing? Yes, because those two segments are congruent, so it really doesn't matter which one you plugged it into. All right, that's basically the end of the lesson. So secants, point of tangency, tangents, and chords are the two things we talked about today. So the big thing we talked about is if you have a circle with a center and you have a tangent, if it comes down, if the radius comes down and meets at the point of tangency, then that has to be at a right angle. And then they're going to very often make sure that they turn this into some kind of right angle so that you're going to use your Pythagorean theorem. And then the second major theorem that we talked about is if this is a point of tangency and this is a point of tangency, and they both come out to a point, these two segments must be congruent. All right, that should be it for today.